Hi, this is Aaron Newcomb, and on this episode of Floss Weekly, Guillermo Amaral joins me to talk to Brandon Phillips about Tectonic, which is a complete and flexible open source architecture for Linux containers. That's coming up right now on Floss Weekly.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Aaron Newcomb and Guillermo Amaral, episode 349, recorded on August 12th, 2015, Tectonic. This episode of Floss Weekly is brought to you by Casper, an online retailer of premium mattresses for a fraction of the price. Because everyone deserves a great night's sleep, get $50 off any mattress purchase by visiting casper.com/floss and entering the promo code FLOSS. And by DigitalOcean. Simple and fast cloud hosting built for developers, you can deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS, that's FLOSS, in the billing section for a $10 credit. Welcome to Floss Weekly, the show where we talk about free libre, open source software. That's what it stands for. Of course, you know that because you're a faithful viewer. If you're not a faithful viewer, welcome to your first episode of Floss Weekly. Good morning. I'm Aaron Newcomb. Randall Schwartz is still not here. He's away. He's cruising around the northern Atlantic Ocean somewhere. I don't know, Iceland, Norway. I have no idea where he is. He's on a boat somewhere. And they don't have a very good internet connection on the boat, so you've got me. Aren't you lucky? Not only me, but you also have another wonderful co-host, and that's Guillermo Amaral. Guillermo, how are you doing?
Can't complain. A little tired, though. I guess I did complain. Tired. There you go.
We shouldn't complain. I mean, we're on the West Coast, right? And, people get up here late anyway. And then the show starts at 8 o'clock. And we're like, oh, we've got to get up so early. Oh, and everyone else is like, stop whining. Knock it off, But anyway, it is early. It feels really early. But so what's been up with you lately? Anything interesting going on?
You can probably notice that I'm not in my usual room bunker thing.
Yeah.
I moved rooms. So I need some posters or something in the background. And I still hear an echo here, so I might need to fix that at some point.
Yeah, I do hear just a tiny bit. And it's probably just because it's just bouncing off the walls and stuff. So, yeah, a couple posters or some. You can put those egg crate things up in the back, make it look like a studio or something.
Yeah, that was my idea, too. I may just buy a bunch of egg cartons or something. Make it, ghetto.
Yeah, exactly. Hey, it works. I had a minor in broadcasting in college, and you can put those things up on the wall. It works fine. You don't have to get the expensive foam, broadcast quality foam. It works fine. But anyway, we're not here to talk about broadcast quality foam. We're here to talk about open source software. So we need to get right into it. And we've got a great topic to talk about today, and that's Tectonic. This is an episode where we're kind of revisiting some things that, at least partially, that we've talked about before, which is CoreOS. We talked about that in episode 314, if you want to go back and look at CoreOS. And our guest was on the same guest was on at that time to talk about CoreOS. But now we're talking about Tectonic, which I believe includes CoreOS and some other things. Guillermo, do you know much about Tectonic?
Not really. I'm more focused into the software engineering side of technology and maybe some hardware there. But sysadmin thing, I haven't done that in years. But so I expect that I will probably learn a lot today.
Yeah, me too. I mean, and I know that there's containers involved, and of course, containers need to be really hot right now. I'm thinking about that meme from Zoolander. If you get a mental image of that, containers, they're so hot right now.
They're so hot right now, yeah.
And with Docker and everything, and it just seems like containers are really, really becoming more important and being used in different ways. So I'm really excited to talk to our guest about how they're doing containers and Linux and how they're using open source, of course, to make all that possible. And we'll get to that in just a minute. But before we bring on our guests, we do have an ad today. We always want to thank our sponsors. Today's sponsor is one of our sponsors, at least, is Casper. Casper, I don't know if you know about Casper, but they're a online retailer of premium mattresses at a fraction of the cost. And so this is pretty cool. In fact, I think there's a video of Leo maybe an unboxing video of Leo taking one of these apart. Basically, they're revolutionizing the mattress industry by cutting the cost of dealing with resellers and showrooms and passing that savings directly to you, the customer. Casper's mattress is an obsessively engineered mattress at a fair price. They use two technologies, latex and memory foam, and they come together for better nights and brighter days. It's a comfortable mattress that has just the right sink and bounce. A Casper mattress provides long-lasting comfort and support. You can buy it easily online and completely risk-free. Casper understands the importance of trying out a mattress. Try sleeping on a Casper mattress today. Casper offers free delivery and painless returns with a 100-day period. This is great. So you don't have to lie down in a showroom. That's uncomfortable. Nobody likes to do that. And you actually get to use the mattress and see if it really works or not. And did you know statistically, lying on a bed in a showroom has no correlation to whether it's the right bed for you, because you just don't have time to actually sleep on it or try it out. And Casper mattresses are made in the USA. So get a Casper mattress today, $500 for a twin, or $950 for a king-size mattress. That's a good deal. Compared to industry averages, that's an outstanding price, actually. And you can save an additional $50 as one of our audience members by going to casper.com/floss and entering the promo code FLOSS, F-L-O-S-S. That's casper.com/floss, and the promo code is F-L-O-S-S. Please go out and do that. That really shows your support for Casper, and we appreciate them, and we thank them for their support of Floss Weekly. All right, so that's enough about mattresses. Let's go ahead and bring on our guest today. Our guest is helping to build a modern Linux server infrastructure at CoreOS as CTO. Prior to CoreOS, he worked at Rackspace, hacking on cloud monitoring, and was a Linux kernel developer at SUSE. And as a graduate of Oregon State Open Source Lab, he's passionate about open source software and technologies. And our guest today is Brandon Phillips. Brandon, welcome to Floss Weekly.
Thank you.
Yeah, I hope that intro was okay. Yeah. Welcome back. So you were on the show before, as we mentioned, talking about CoreOS, and now you're back. It looks like things have expanded into maybe a more complete set of technologies, kind of taking everything together and using it to build a complete platform. So tell us a little bit about Tectonic.
Sure. So what Tectonic is it's a combination of bunch of technologies that we built and a number of open source components that we've contributed to. So we kind of started the CoreOS journey by working on this thing called CoreOS Linux, which is a Linux operating system with some interesting properties around how it does its updates and how it's designed without a package manager. We can go into those details later. And then distributed systems components that we built a distributed key value store inspired by a Google white paper called the Google Chubby paper. And this is really critical for creating a fault-tolerant kind of control plane for a large set of servers that need to coordinate to deploy an application. And then on top of that, we built a number of ancillary technologies like Flannel and Rocket that are necessary for packaging and doing networking inside of this sort of type of infrastructure. And then the most important piece to the kind of Tectonic story is this cluster management system that was originally open sourced and kind of backed by Google. And this is called Kubernetes. And Kubernetes kind of helps take this container stuff that's been really exciting recently and pair it with, on the other side, with the necessary things in an infrastructure, things like service discovery, load balancing, controlling and managing how many copies of the application is running so you can scale to the number of requests per second that you're getting, or help do automated rollouts from version A of your software to version B. So Tectonic is this complete stack backed with 24/7 support and some additional dashboards and stuff to kind of help people introspect how the system is running. So yeah, it's CoreOS Linux all the way up to a cluster managed API server and stack that's Kubernetes.
Great. And I think actually we're going to talk about Kubernetes next week. If I'm not, let's see, who's coming on? I'm going to talk about this at the end of the show too, but Tim Hawken and Brian Grant are coming on. That's not next week; it's 2 weeks from now. But we'll talk about that at the end of the show. So just so you know, they're coming on as well. So we're actually really excited. And I really hadn't heard. I mentioned them last week when I was talking about upcoming shows, and I hadn't really heard about them for whatever reason. I guess I'm busy, and I was. I actually do know the reason. I was busy, but I hadn't really heard about them before. I didn't even know how to pronounce it, and so this is kind of a great intro for them as well. So. So you're using, I think you mentioned CoreOS, right? Obviously, and Docker, right?
Mm-hmm.
And Kubernetes. Those are the basic three pillars to make this whole thing come together.
Yeah, there's some other technologies that we've built and that we've taken from the open source community too. Things like etcd, distributed key value store, which is the backing of Kubernetes. It's the database that Kubernetes stores all the critical information it holds onto into. And then Flannel, essentially Kubernetes has this very interesting network topology that's a little difficult in a lot of environments. And so we built an overlay networking system that uses etcd as its backend as a way of making a consistent networking environment for this kind of complex distributed system that Kubernetes sets up and manages for you.
Cool. So what would I use this for if I was, maybe starting up some sort of an application I wanted to host online or something? I mean, take us down the typical use case for Tectonic.
A really clear use case is you see a lot of organizations, they build some application. Let's make it really simple. We'll say that it's a Node.js application, so it has some business logic and it talks to a database. Very straightforward sort of platform. And what they have to do almost every time is they have to build out, well, what does it mean to deploy a new copy of this application? How do we roll it from version A of that application to version B? What if we have a copy of the application misbehaving? Maybe it has a memory leak or something. How do we isolate that away from the load balancer so we can investigate further? So there's a lot of this kind of tooling that has to happen when you start developing an application that you need to kind of build around. And Kubernetes is kind of a kernel, if you will, or an API that helps manage this application lifecycle and this load balancing, this service discovery that is pretty critical to any back-end internet application. And the whole thing is that it's inspired very closely by lessons learned and tooling inside of Google. And so you find that if you work or if you look at these large organizations that have large web properties on the internet, they found that these sorts of platforms like Kubernetes are pretty critical to building really reliable services, and then services where engineers can be really effective at rolling out new features and bug fixes to the users in a timely manner. Great.
So I would ask the question next, why CoreOS? But for those that haven't or don't want to go back and watch that episode, maybe just a quick rundown of CoreOS and what it is and why that brings value to this particular stack.
Right. So an interesting thing that Kubernetes does is it makes for a nice clean API between the engineering team and the team that's maintaining the infrastructure, the networking and the hardware and that sort of thing. And we're really interested at CoreOS in building these kind of abstractions where it's very clear what the responsibilities are. What's kind of happened in these, in a lot of the general purpose distributions, that it gets pretty mucky. When I update my operating system, my application may break. And this is something that we wanted to solve with CoreOS, primarily because we wanted to be able to push automatic updates to the servers. And so containers are a way of doing that. And in a similar way, Kubernetes relies on container technologies to move these applications around inside the cluster. And so CoreOS is the best place to run containers, and Kubernetes relies on all of these technologies in order to actually get its work done of getting a process running inside of the cluster.
So they really are, I mean, maybe not tailor-made, but it seems like they're made really well for each other. They work together really well, like you mentioned, in terms of the software updates. And how many of these are you going to run? I mean, how does this scale? What's the typical scale look like? Is there an upper limit, or is there a lower limit you have to start with to get into this?
Yeah, so there's not really a lower limit. You could very comfortably run Kubernetes on a single machine, and this is great for just being a developer and testing out and getting the whole stack running. But Kubernetes scales well too. I think a lot of people would be hard pressed to have an application infrastructure of reasonable size that Kubernetes can handle. Right now, the target is around 100 machines for this initial 1.0 release, but we're working along with Google and everybody else in the Kubernetes community to get that scale number up. But in a lot of cases, what Kubernetes does is that you find a lot of infrastructures are running at pretty low scale. The servers are sitting there pretty bored. And so Kubernetes, since it uses a scheduling system and kind of packs in applications and services that you want running on your infrastructure, it can make more effective use of your infrastructure than you would normally do.
Right. Oh, we're going to get into infrastructure in a minute because I'm interested in how this all gets set up and everything. But I want to make sure we cover some of the more basic questions first before we get there. It's hard for us because we're technical people and we like to jump right into the details. But tell us first a little bit more about Tectonic itself and how that relates from a business perspective to CoreOS. Is it the same company? Is it different companies? How long has it been around? Is it relatively new? I mean, tell us a little bit about Tectonic itself, the company.
Sure. So Tectonic is a brand that CoreOS Incorporated has. And we made kind of a conscious decision that we wanted to separate out the commercial brands of CoreOS from the open source brands. We've done I think we've done a great job at building these open source products that are well respected and widely used throughout various infrastructure users. Things like etcd and Flannel and Rocket and CoreOS Linux itself. And so we wanted to kind of just be conscious and make it clear when we're commercializing something versus when we're building something in open source, just so our community has a strong signal of what's going on.
Okay, and so if I wanted to set this up for myself, I guess I could try to set it up just using the open source programs and packages. I could try to cobble this together on my own. But really, what you're doing is you're offering. I mean, it is a complicated thing. Let's be honest. What you're doing is you're saying, look, we're going to offer support and support this. Is there going to be any difference in the code base between Tectonic and then if I wanted to do it myself? Are there going to be bits that are proprietary or anything like that?
Yeah, so we try to do a really good job of making it easy for if you want to go off and read the instructions and bring up a Kubernetes cluster on top of CoreOS Linux. We want that to happen. We want to make it easy for people who want to gather up the open source components and get that stack running. We want that to happen. With Tectonic, what we do offer is we offer support. So we have 24/7 support for a user who's running Tectonic. And then also we kind of help guide you through the process of getting it running inside of your infrastructure, being that reliable set of experts that you can call up and ask for help and get the thing set up. And so Tectonic, what we utilize is essentially upstream Kubernetes. In CoreOS Linux, we utilize upstream kernel.org kernels. But what we do is we add on proprietary software too. So we have things like the dashboard and other components where they kind of add value to the overall cluster. But the idea is that we want to use and participate in the upstream open source community and make sure that that's a really solid piece of infrastructure.
Great. And then are you also accepting feedback from the community for these other projects? So, I mean, if people are finding that there's something wrong, I mean, can they contribute back to like CoreOS or I guess you can speak for Kubernetes at this point or Docker, but I mean, is there a spirit of contribution going on here, or is it primarily just, hey, we've got these core engineers and they're working on this and we'll take your suggestions?
Oh, no, for sure. We work really hard to make sure that people feel that their contributions are valued and that we're actually communicating with the open source community. Our engineers are merging pull requests from, committers that just come by and have a single pull request. We also have a number of people in the community who participate on a really regular basis in our open source communities too, taking on entire features and shepherding them through the merge process. And this has been something that we've been doing the whole time. We have hundreds, probably thousands of contributors at this point who've either filed a bug, submitted code, fixed up our docs, given talks at various meetups about the technologies. Our intention is not to just open source something and throw it up on GitHub and call it a day. It's actually a conscious investment that you have to make. And we want these tools to be good, solid tools that people feel, even if I'm not using Tectonic, even if I'm not using CoreOS Linux, I want etcd to run well on top of Ubuntu and Fedora and everything else too.
Okay, so could you give me a little more information on what etcd does for a system? Sure.
So when we started building CoreOS Linux, one of the things that we wanted to do was these automatic updates. In order to do automatic updates correctly, you need to actually reboot the systems. And this is because the kernel requires a reboot in order to apply an update. And the kernel, in a lot of cases, is the piece that is the scariest upgrade. So we want this thing to happen regularly. We want these kernel updates to be applied regularly. So this requires that we reboot the systems, and whatever work was going on in that system ideally happens somewhere else. So it gets moved somewhere else. And so we built etcd inspired by this paper that Google has called the Google Chubby. And it's a distributed system. So etcd is a database. You write keys and values into the database. Foo equals bar, you write that into etcd. And then it gets replicated across, say, 3 to 5 nodes in the database. And what that means is that you have safety that if one of the machines in that 3-machine cluster goes away for an update, or Chaos Monkey comes in and pulls the power out of your server, or you get a network partition or something like that, that the cluster is able to continue running with the other 2 members of the cluster, and that you're still able to read and write those keys safely. So it's kind of built with the idea in mind that disaster is going to happen inside of any system, and we need to design against a single point of failure. And it requires a lot of computer science, distributed systems, consensus algorithms to get there. But at the end of the day, what you get is you get a key value store that's replicated, consistent, and can be used to build these higher order systems like Kubernetes on top.
Okay, but before you mentioned that I think CoreOS has no package manager, does etcd play a part in that?
No, so etcd is just used for coordination across multiple machines. So it can be used for coordination of DNS. So there's a DNS server that's backed by etcd, coordination of load balancing. So there's a load balancer called vulkand, which is backed by etcd. It can be used for scheduling. So there's various schedulers that have been built on top that store their information inside of etcd. So Kubernetes is an example. We built a scheduler called Fleet. There's other schedulers that have been built. So it's about this coordination piece of what's actually happening inside the cluster, and I want to have that replicated so that I don't lose it in case of a single machine failure. The package management, what we do inside of CoreOS is we rely on containers. And the reason we rely on containers instead of a package manager is that a container isolates the application from the operating system. And that means that we're able to upgrade the operating system over time and have a good guarantee that the operating system being updated isn't going to break the application, because there's a clear API between the two.
Okay, so I'm guessing it's kind of similar to like BSD jails then?
Yeah, container you can think of, if you want to go all the way back, container you can think of very simply as a chroot. And that's really the big thing that people use it as. It's a way of building a chroot. So a chroot is a file system that contains, say you have a Python application, a chroot would include Python and then your application together in a single file system. And so this means that if your application relies on Python 2.7, but your OS installed Python 3, it's okay. You install Python 2.7 in the chroot along with your application, and then you move that chroot around between hosts, and it runs in the same way. So it's something like BSD jails, but really the property that gives us this abstraction is the chroot abstraction.
Okay, well, we mentioned what etcd does. Is there anything else in this whole stack that an average Joe like myself with a Linux desktop might be able to use to like make my life better?
Yeah, so another piece of tech that we've built is called Flannel. And in Kubernetes, each of these applications, so say I have a Redis server, or then I have my Python web application, each of these containers gets a IP address. And so this is really, really useful, because if it has a real IP address, I can put it behind DNS and I can allow it to listen on port 80. And so Flannel, what it is it's an overlay network. So if you have a couple of machines that you're playing around with, but they get, say, a 192 address from your DHCP server, you can use Flannel to set up an overlay network so that when I start launching things with Docker or some other container runtime, the applications, when you launch them, are able to talk across the network using this kind of IP address. So this is really it's a very nice abstraction, and it allows for things to fit into kind of classic service discovery mechanisms like Nginx load balancing or DNS or that sort of thing.
So you mentioned chroot, which I always say chroot. I mean, that's what we're talking about, right? Yeah. Just at the risk of losing, I've used it before, but maybe some people in our audience haven't used it before. I believe it stands for change root, the root of the file system. But maybe explain a little bit more about chroot. I just want to clarify some of these topics, because we're comfortable talking about it, but then I know sometimes we have some beginner listeners, people beginning Linux and things like that. So I want to make sure we explain some of these things we've been talking about. So okay. Can you explain real quickly chroot for us?
Sure, let's do that. So let's go to the package management abstraction. So I'm on my Linux laptop and I do apt-get install Python. What happens is that it goes over the internet. It downloads a file that includes Python and a number of other Python files, like user bin Python, for example, and places them in my root file system. So I'm able to type in /user/bin/Python into a bash terminal, press enter, and I have a Python prompt. So this is installing it into this global namespace of my laptop. Now, what a chroot does is it allows me to create new root file systems. So we all know that the root file system of a generic Unix machine is /. Well, I'm able to say in my home directory create a new root file system. We'll call it new root. So I make dir new root, and I go in there and I can copy in, say, user bin Python. I can copy in libraries that are required to Python into that new root directory. And then what I can do is run a command called chroot. And I go chroot new root and Python, the command I want to execute. And what will happen is that I'm executing not the Python that is on the host operating system, but the Python inside of that new directory. And so you can imagine using this as it's used as a way of testing package management systems. So I'm a developer working on apt-get, and I want to make sure apt-get works. So I set up a root file system, a chroot that looks just like my host operating system, but it has a new copy of apt-get that I just made a patch to. And so I install that into the chroot, and then I run apt-get in there. And I'm not at risk of corrupting my apt-get that's on the host operating system. So it allows for you to create kind of these really lightweight new machines, but they share the kernel instead of how a virtual machine works, where it's actually I'm creating a new operating system instance all the way from the kernel up. This is just from the file system up.
Right. So even to go one level higher, I would say for people that are used to Windows, for example, you have that C drive, that main drive on your system, and then you have all of these subdirectories under it. This would be like taking Skype, let's say, that's running on your system and putting it in a directory all by itself and calling that the new C drive. And it's going to run over there by itself. It's still going to use all of the Windows files that are on your hard drive, but it's going to run there kind of isolated a little bit on its own, so that when you have a new version of Skype, you can start that up, or an old version of Skype for that matter. You can start that up on its own and see how runs and how it works, which you can imagine is very important for software development because you have to be able to test multiple versions, see if they all work, and see if anything's going to break. So I just wanted to give that a higher level for folks that aren't used to the way Linux file systems work. But so take my example and then go from there back to Brandon's and apply it to Linux, and you'll see how all this works together. And hence the reason they're called containers, because you're basically boxing things up into their own little space so that you can run them in an isolated way and make them work. You mentioned that you're able to do. Is any of that wrong, by the way?
No, seems good. I'm not a Windows expert. It seems good.
I'm not either, but I just wanted to I always wanted to try to make sure that we cover it all so that people can make sense of it. So you mentioned that you can do. This also allows you though to do kernel updates as well online without rebooting. How does that work?
No, so we take a reboot. There are technologies to make the kernel reboot faster, but you kind of have to. It's like reloading an application, only it's way more inconvenient because machines are slow at booting. It's something else I want to fix, but that's another topic.
Right. Well, I was just wondering because I think Oracle Linux has a claim. Oracle Linux is based on Red Hat, and they have a claim that unlike Red Hat, if you run Oracle Linux, you can do kernel updates without reboot, without disruption. I don't know how they do that. I used to work at Oracle, but not in that group, so I don't know how they're doing
there's
that.
a big asterisk next to that one. So you're able to do some kernel updates, not all of them. And so it's a way of kind of delaying the inevitable reboot. So it can be useful if you have a heavily loaded machine. But what we want to do is create distributed systems where no machine is important enough to not take a reboot. So it's kind of a difference of design requirements.
So for containers, are there? I guess you would probably need to ship all the dependencies required for an application every single time, or how is the dependency thing worked out there?
Yeah, so that is true. Essentially, what happens is the container has all of the dependent things. So I'm writing a job application. This will include the JVM and everything inside of creating a JVM environment along with my application. There are some things that can be done with containers to kind of deduplicate that, so I don't end up with hundreds of copies of the exact same piece of software on my server, to kind of save on space and just save on transport when I'm installing a new version of a container. So, but that is kind of the critical change with how software is packaged with containers versus a package manager, is that the application comes with all of its dependencies. And what we're relying on is the very low level syscall interface of the Linux kernel, instead of relying on the package manager to kind of give us this huge amount of API surface area.
So for chroot, you would probably need all the system files, right? You would need a copy of your user bin and at least a trimmed down version of that. Do containers also require that part?
It depends. So for some applications, say like a Java application, this isn't necessary because all you have is the class path and the JVM. For other things like Go applications, I don't know if you're familiar with the Go programming language, but Go is able to compile down to a single static binary. And so you just have essentially one file in that container, and it's just the Go application. So in a lot of cases, you don't need the full operating system in there. You just need the requisite bits in order to run your single application. And so that means you probably don't want Bash in there. You probably don't want, Netcat in there. You just need the Python interpreter in your application or JVM in your application, that sort of thing.
Great. So I know we're talking about nitty gritty, but we're going to talk about the ultimate implication of all of this technology in terms of making a Google-like infrastructure that's available to anyone. We're going to talk about that in just a minute. But first, we want to thank another sponsor of today's episode, and that sponsor is DigitalOcean. Whether you're an expert code warrior or just getting started, you'll need flexible, reliable, and affordable hosting, of course. and that comes from DigitalOcean. They provide developers with droplets, which are virtual private servers that can be customized and deployed quickly on host websites, web app production applications, personal projects, virtual desktops, almost anything you can think of course, with full root access. That's very important for our listeners. So DigitalOcean is built for developers. It's used by over 400,000 of them. You can deploy and configure your droplets via a streamlined control panel or a simple API. They make it really easy to deploy these things. One-click install allows you to deploy apps like Django, Docker, what we're talking about today a little bit, Drupal, LAMP, GitLab, many more. And the servers are built on hex-core machines with dedicated ECC RAM and RAID SSD storage, which is really important because it really makes your applications run a lot faster. So it's great that they're offering that capability. Servers can have up to 20 CPUs, 64 gigs of RAM, and 640 gig of SSD hard drive space. So it really scales really nicely to meet the demands of even the most challenging applications. You can do auto backups and snapshots to clone and deploy resized droplets as you go. You can deploy servers in regions all over the world with gigabit speeds and 99.99% uptime, which is great. We mentioned the web console access. You can actually use HTML5, SSH, SFTP, KVM, or VNC for virtual desktops. A lot of acronyms there, but it all means that you're going to get a great experience when you use DigitalOcean. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. It's like the magic button. So DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 per month. And there's also hourly pricing available starting at less than a penny per hour. But we're going to make it easy so you can get started today and deploy an SSD-based cloud server for free. That's right, for free. You can go to DigitalOcean.com right now and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code. This is really important. Enter the promo code FLOSS. We want to show them our support here, so they'll keep being a sponsor of Floss Weekly. We love it that they are. But you get a free $10 credit for entering that promo code FLOSS. And that's plenty to get you started. Believe it or not, just $10. It's plenty to get you started and explore what DigitalOcean can do for you. That's DigitalOcean.com. And once you sign up, enter the promo code FLOSS in the billing section for a $10 credit. And we thank DigitalOcean for their support of Floss Weekly. All right, so let's talk now about, let's get back to Tectonic and what you can ultimately build with Tectonic. I mean, I know one thing that I think you've talked about is building this Google-like infrastructure. Google is well known for building a scalable, reliable, distributed systems in general to support all the things they do, like search and Chrome and maps and all of these things that they roll out. That's basically how they do it. Is they have tremendous scale and they can build these distributed systems up into the thousands and tens of thousands of nodes and things like that. So, is this really what we're talking about with Tectonic? Is that really possible?
Yeah, the idea is to give those same abstractions that Google engineers rely on, and to make it clear when you're working on infrastructure versus when you're working on the application. I think a lot of what teams struggle with who are working on system administration of Linux hosts today is it's this interdependency of the operations team needs to know what are the dependencies for the application, how do I need to configure the network, what is this particular machine inside this particular rack going to be doing? Is this going to be a load balancing machine? Is this going to be an application server machine? And this means that it's a lot harder for just to get the application out there in front of users and get it running. And so what Kubernetes does and what Tectonic does through its relationship is that it provides a cleaner abstraction. So we no longer think about individual machines and what those individual machines are running inside the data center. Kubernetes gives us abstraction where I'm able to say, I want this application running. It needs to have this much RAM and CPU, etc. And I need 12 copies of it running. And Kubernetes takes care of getting that thing running inside of your infrastructure, ensuring that, if the intern trips over a power cable in the data center, that job gets moved around, and that sort of thing. So it provides this abstraction and this API. So we stop thinking about the individual server and this individual rack and start thinking about the whole culmination of what is the cluster, what is the data center that we're actually deploying our application into. And that's how you start to, generate these efficiencies where an engineer is empowered to actually, take an idea from source code to behind a load balancer on Google.com, and because they have this abstraction in place.
So what about, I know Google does some hosting things as well. I mean, if I were to use Google hosting, or I'm trying to differentiate this from a number of other technologies that are available today. So, there's, of course, internal to the company, I could use virtualization on a server, right? And we mentioned this a little bit before. And then there's also things like Amazon AWS or Google hosting, which they'll host my app. And how is all of that different from what we're talking about here with containers? How does that differ from what we're talking about? When would you use those different technologies, and then when would you use something like containers to build your application on?
Right. So kind of the promise of virtualization 10 years ago was that it was going to make it really easy for engineers and infrastructure people to get their application and package it up and deploy it onto infrastructure. What actually ended up happening is it's really difficult for a lot of teams to build this full operating system image. Now suddenly, instead of just being in charge of their application, they're also in charge of making it boot, making sure that it has all the necessary agents and components to talk to their cloud provider, needs to install SSH keys. And so the problem got moved around in a way where taking a piece of source code and getting it running inside of an image, kind of this static golden image of the application, took a lot of work and a lot of tooling. And it generally happens on the order of hours that I commit a piece of source code and then we have an image that's running on top of a cloud provider like AWS or GCE. What containers give us is an abstraction that just moves faster. So instead of taking hours of, I build this gigabyte-sized image and then I upload it to my cloud provider into each region, which can be a lot of management. The container, I can take my source code, build it, and upload it to a container hosting place, usually in the order of seconds or minutes. And so it just accelerates this life cycle. And a lot of engineering happens because engineers feel like something's taking too long. There's that XKCD comment, like, can't work, it's compiling. And virtual machines kind of have had that similar life cycle of, I can't work because the golden image is building for the next hour and being uploaded to our cloud provider. So containers are essentially delivering on that promise in a way that works at human scales, where human doesn't get bored and goes off and get a snack.
Right. So thank you. That's awesome. Because I don't even. It's hard for me to still explain containers and why people are like, oh, well, why don't I just run? Why don't I just get a big server and run 10 instances of Linux on it, or Red Hat, or whatever their favorite flavor is, and do my development there. And I think that's another interesting aspect to this. We've touched on it a number of times, but there's a problem with development, not just running your application, your production application, but there's a problem with development. And just one more time to make sure we're clear on this, how does something like Tectonic speed development? How does it help developers get their applications to market more quickly?
Yeah, the big thing is that once you have your application packaged in a container, that process is really fast, but the container just solves part of the problem. It solves the part of the problem of packaging and getting it onto a server quickly. Now, once it's on the server, there's a lot of things that you need to do. You're running your current application, and you have the new version of your application that you're super excited about and want to get in front of users. So now you have to figure out, well, how do I drain the load balancer and add this new application in? Or you need to figure out, well, this application was running, version A of the application was running, but there was a bug in it, and this one thing crashed, and I want to isolate that one copy of the application so I can inspect it and then figure out the bug and fix it in the next version. And so these operations kind of require more than just the container. They need this service discovery, this infrastructure piece, so that you can go in and actually do the hard parts of software engineering, which is rolling out new code and then finding bugs and just keep that life cycle moving along. And that's what Tectonic helps people do, is kind of build a infrastructure, a distributed infrastructure that's reliable, and then give you the APIs and the mechanisms whereby you can get your job done kind of quickly without a lot of coordination across different teams.
Mm-hmm. Mm-hmm. And that's really important. If you go out, we talk about this a lot at where I work, because I work at a storage company, and we talk a lot about, well, how does storage really matter if I'm developing an application? Like, they seem to be two different worlds, or it seems to be a little bit abstracted from the development process. But actually, if I can help you make storage copies more quickly, or move them up to the cloud and back down, or something like that, then there's actually a benefit there. And if you're not familiar with application lifecycle development, you can go out and just Google that. You'll find lots of images that kind of help you piece together the various components that are used and how it impacts. You can see how the speed of debugging something, or the ability to isolate things and get things done more quickly can really help with the development process. So I'd encourage you to go out and look at that. So who's using this? I guess that's the next question. I know it's relatively new still, but do you have people that have set up these types of infrastructures already? Are people using it? Can you give us some examples, maybe?
Yeah, for sure. So there's a software company called Jive, and what they do is they deploy their application, and they deploy their application essentially one per user. So you get your own, say, flossweekly.jive.com instance. And you're able to log in and do that sort of thing. So it's software as a service, but it's single tenanted for your users. And so they have this application that they want to upgrade. They want to roll out new versions. They want to deploy lots of copies of it for each individual customer. And so they've prototyped and started working through, how do we move from this custom deployment stuff that we had been running before onto Kubernetes, because it solves a lot of these problems for us. In a way that provides this nice clean abstraction, and we're able to kind of maintain this life cycle for our users and for ourselves of upgrading the software and getting it behind and in the hands of the users.
Could Tectonic or any of these technologies be used for continuous integration? For example, if I work as a software engineer, so I sometimes need to set up different machines to build for different architectures. Could any of these technologies be used for that?
Yeah, for sure. So another great example of somebody building on top of Kubernetes is CloudBees, which is the company that does Jenkins. They built a Jenkins plugin that uses the Kubernetes APIs to farm out work to individual workers. And so CI systems kind of classically have had this similar sort of infrastructure set up, where there's this control machine and then a number of worker machines. But it's kind of a custom thing. You don't kind of introspect it in the same way that you would introspect your production environment. But you can kind of start running, because we have this shared kernel of the Kubernetes APIs, we can start running this kind of mixed set of applications, our CI systems, our production applications, on a single set of machines. And it all works because of the isolation that happens in containers. So I can safely say, well, this machine has an additional gig of RAM and some CPU cycles that aren't using. It's okay if it participates for the next few minutes in a build of our software through the CI system. And so the abstraction is kind of flexible in that way and can be used for doing things like CI.
So I guess I couldn't be building software for a Windows target on this system, would I?
You could imagine one thing that hasn't been talked about a lot, but is a really interesting use of containerization, is that you can do what people kind of jokingly call a double hold container. But a virtualized host is just an application at the end of the day. So you can imagine running Windows inside of a VM. And that is actually just a container itself, because the VM is just another process running on top of Linux. So you could imagine, spinning up a Windows container, and then talking to that Windows container over the network, just like you would normally for a normal Linux application. And that's pairing virtualization with containerization is something that we're interested in doing at CoreOS because it provides for really nice security properties. I don't think just because containers are taking off, there's any reason to throw out some of the nice security properties of virtualization. It is a tool, and it's a tool that the hardware kind of helps make the system more secure.
That actually does sound a lot really interesting rather. Especially if you do have a Windows image or maybe a Mac OS one, if you work around the license issue there, you could probably just have a clean one and then launch that one when you need to build something for that platform. Then that does sound interesting. For somebody like me who maybe gets interested in wants to participate in your project. Is there any special protocol I would need? What languages is this project written in? Would I need to know Java?
Yeah. So probably a great resource is coreos.com/community. And that has links to mailing lists on our various open source projects. For the most part, all of these projects that I've been talking about, Kubernetes, etcd, Flannel, etc. They're written in Go. Go is this programming language that came out of Google about 4 years ago. It's a statically typed language, but people who are familiar with Ruby or Python have a tendency to pick it up really quickly. The thing I love about Go is that it very much is inspired by the tradition of C, and getting started with the language and looking through the language definition and tutorials is very short. There's very, very little to learn there. People who are interested in getting involved, pretty much the minimum prerequisite is an understanding of Go. Of course, there's other ways of getting involved. We have lots of documentation. We have lots of bugs that need to be found and triaged. And so there are ways of getting involved that don't involve just writing code.
Yeah, and in fact, if people are interested in learning more about Go, there's a FLOSS Weekly that they can go take a look at. It's FLOSS Weekly 284. And Go keeps coming up more and more often. It really seems to be taking off. So I think I may have to spend some time with Go. As you mentioned, the ability to create a binary of your program and all the associated libraries, I assume, in order to go do that is something that's really interesting to me, because I used to I shouldn't go into this. We always get off on these tangents, but I used to write Perl programs, and the problem was they had to run on different systems that had different levels of Perl installed on them, and they had different operating systems. It was AIX, it was HPUX, it was Linux. And so by being able to create a binary and just have it run, it was fantastic because I could distribute my application around to multiple systems and I didn't have to worry about incompatibilities and things like that. I don't know whether that's possible with Go, but I assume it is if they have a binary compiler.
Yes, you see sysadmins using Go a lot recently because of this property of it's just a binary. At the end of the day, it's a single statically compiled binary. So I can be on my Windows laptop or my OS X laptop. I can write some script or some code that I need to be running on my servers. I can cross-compile it from my laptop really easily to a Linux binary. I S-copy it up to the server, and then I just run it. And so, without containerization or anything, it provides this really nice abstraction of just a single binary that can run anywhere that Linux works.
Yeah, that's cool. That's really cool. I'm going to have to check that out. Find some time to start messing around with Go. A couple more questions. We're almost out of time. The first one is how difficult is this to implement? We mentioned scale before, how it scales up and down and things, and that's great. But like, if I would just want to get started, okay, I've heard you talk about this, and it sounds really interesting. And okay, where do I start? Is there packages I have to install? Is there like a wrapper package that installs everything for me? How easy is it to get started to actually implement this and start playing with it?
Yeah, if you want to play around with Kubernetes and etcd and CoreOS Linux stack, it's pretty straightforward. We have instructions on coreos.com/docs that use all open source components. And so it really is just a little bit of light configuration, and you're able to launch a single VM that has this API, and you can start playing from your laptop with the kubectl command line tools. So it's a complicated stack. There's a lot of moving components, but at the end of the day, what you're talking to is a single API endpoint that kind of encapsulates all the complexity underneath that it covers for you.
Great. And in terms of reliability, we know that there's nodes that can go down and you can keep your application running. But is there any sort of single point of failure involved in the system? Is there like a master node or something that if that goes down, everything kind of stops working or anything like that? Or is it completely redundant across the stack?
Yeah. So Kubernetes has a very well-designed system that avoids the single point of failure problem. So there's the idea of the control machines and then the worker machines. And if the control machine, powers off or something terrible happens to that machine, the worker machines continue just doing their stuff with no interruption. So if you lose the actual Kubernetes control plane and the API server and all that stuff, your application essentially just continues running as if nothing happened. At some point, you'll obviously want to bring that control machine back up. But it is designed so that the whole thing is kind of self-reliant.
Yeah, great. And then also, is this targeted more at people that want to run on white box hardware, kind of like cheap, fast, small systems and a lot of them? Or could you run this in production? I'm thinking of can I go out to a big box distributor and run it on that hardware as well? Or is it really just geared towards, no, we're just going to go either build our own servers or deploy it on white box servers and storage?
Yeah, the whole thing is designed to run anywhere Linux runs. So we have users running it on AWS, Google Compute, DigitalOcean. So the cloud provider sort of locations, you can run this stuff. Other places that you can run it are, just on your white boxes that you have racked up in your servers already, and we provide instructions for that. And also, there are various system integrators like Redapt or any of the large system integrators that can kind of sell you hardware that's designed to work with this whole stack and it's kind of optimized for it all. So it can be the whole spectrum from, hey, I'm playing on my laptop with VirtualBox to I'm actually deploying it on some custom gear that we bought just for this purpose.
Okay, awesome. A couple more quick questions. So there's something called Rocket. I don't know if we've covered that. What is Rocket?
So Rocket is a container runtime system that we started building really late last year. And Rocket kind of tackles a few things that we wanted to see solved in the container ecosystem. And this is primarily around things like security and then how containers interact with the classic way that services and processes are launched on Linux systems. And so it was essentially what we're doing there is we're wanting to build a container runtime that has kind of a more focused approach to how security and process model and kind of how these container runtimes are put together. It's a lot of technical details of why we built it. There's a great blog post that we wrote about why we built it, but it is a container runtime that is comparable to something like Docker, but with this very process model, runtime, security kind of focused thing.
So does one replace the other, or are they complementary somehow? I mean, between Docker and Rocket.
Yeah, so Rocket is able to run container images like a Docker container image. So in a way, it does replace Docker. So it implements a lot of the same functionality, but the implementation details of how we actually get there and how we do it are, again, done with this focus on process model and security, which are things that we've kind of struggled with how the Docker daemon is put together. And so this is kind of our perspective on how these sorts of container systems should be put together and built.
Yeah, so that's my next question is what can we expect in the next 6, 12, 18 months in terms of Tectonic? Is this one of the things we can expect is that Rocket will maybe displace Docker at some point?
Yeah, so again, the container runtime is sort of an implementation detail of Tectonic and Kubernetes. What we want at the end of the day is for an application, a person writing an application to build that application, sign that application ideally with their public key, and then upload it to the internet, and that to be the end of the process. They don't care about how it actually ends up running on the host operating system. And so with Rocket, what we'll continue to do is integrate it into existing things. So Kubernetes, for example, is able to use Rocket as a alternate container runtime to Docker. So we're able to, take in a user's instruction to run this container, and Rocket is able to launch that container on behalf of the Kubernetes control plane. And we have another release coming up, Rocket 08, in the next couple of weeks. That's going to have some new security features and some new runtime features, with the focus on again, this process model and security stuff.
Great. So we're about out of time, so we need to wrap this up. Is there anything that we haven't talked about today that you want to make sure people are aware of?
I think the primary thing is that people who are interested in free open source software, I want to make it clear that we'd love to have your help, and that we have a lot of interesting open source components that you can get involved in. So go up on the coreos.com community page and check it out. And again, it's anywhere from, I'm a software engineer, I just love this stuff and I want to help hack on it, to, we have conferences and meetups and stuff that you can participate in, documentation that can be written and fixed up, bugs that can be hunted down and kind of triaged. So there's a lot of work that can be done there. And then, of course, if people are interested in kind of having a commercial version of all this stuff that we've been building, tectonic.com, and check out the Tectonic preview. Okay,
fantastic. I was just going to ask you where people should go to find out more. So you covered that one for me. I appreciate it. That was easy. All right, so I've got a couple questions that we usually ask at the end of the show, and so you get to answer them as well. The first one is, what is your favorite scripting language?
Ooh, at this point, Go is my scripting language of choice.
Nice.
I do rely on Bash quite a bit, but it's usually those one-liners right on the command line.
Right. Well, so then there we go. That's the next question: is, are you related to that? Is VI or Emacs?
Oh, definitely Vim. Vim for sure.
Nice. Nice. Yeah, I know. It's funny because Randall loves Emacs, and so we always ask that question. And I think the majority of us, I don't know what it is, we would just like VI better. So I've been using Nano a lot lately myself, just because I've been hacking on Raspberry Pi, and Nano's there, and it's just easy to use. So I'm becoming more of a Nano fan. Actually, I'm getting used to using it, but it's not as easy as VI. You can't. Anyway, we won't go into all that. We don't need to have a show about VI.
Perfect.
But great. Well, Brandon, thank you very much for joining us. It's been a pleasure to talk to you, and congratulations on Tectonic. It seems really, really interesting. I hope a lot of people go out and check it out.
Thank you, and thanks for having me on.
Yeah, you bet. Good to see you again.
Cheers.
All right, so that is Tectonic. What do you think, Guillermo? Do you like Tectonic? Are you interested? Are you going to check it out?
I'll probably try and use it for CI, as I mentioned. I'm not really interested in trying to see if I can actually get a full compile stack working with it. Let's see what happens.
Yeah, sounds good. That sounds really good. I think I've learned a lot today. I don't know about you, but just this whole. The way we deploy applications keeps changing and keeps evolving, from virtualization, to cloud, now to containers. Like I said, containers seems to be really hot, and Docker seems to be picking up steam. I know at my work we've started doing some stuff with Docker on our converged infrastructure stack, and so potentially maybe this is another way to go down the road, is to take a look at a more complete stack, not just Docker, but also CoreOS and Kubernetes and things like that, and see how it works together. I think it would be really interesting, especially for potential developer environment and people that are developing things at scale. I think taking a look at this type of supporting infrastructure base for developing your applications is really, really important. And it looks like things are humming along smoothly here. So I think it's pretty cool. Speaking of things that are pretty cool, we've got some pretty cool guests coming on the show. How's that for a transition? Coming up, coming up soon. Next week, Randa will be back, and we're going to be talking about the network time protocol. Ooh, it makes things run and makes us not lose track of time. Harlan Sten's going to be on to discuss what's going on with NTP, and I think that's going to be actually more interesting than it sounds, just because so often servers use NTP to set the time on their clock, make sure their applications are running and they're synchronized correctly. A lot of applications, if the time's different on two different machines, it comes back and says, time's different, I can't run, I'm going to quit. So I think that'll actually be a really interesting discussion. And then on August 26th, I know we talked about it a lot today, but we're going to go in depth on Kubernetes. So if you are interested in the discussion today and interested in that piece of it, definitely be sure to join us on August 26th. We'll be talking about Kubernetes some more. And then on September 2nd, we're talking about something called FW NOP or FW CNOP, which actually, I mean, it stands for Firewall NOC Operator, which makes more sense when you actually spell out the acronym. But it implements an authorization scheme called Single Packet Authorization. So we're going to get all security up in your security with FW CNOP. And then on September 9th, we're going to be talking about Gambas, which is a free development environment based on the BASIC interpreter, believe it or not, with object extensions. And it's kind of like Visual Basic, but they say on their website it's not a clone of Visual Basic. So that actually sounds interesting to me because I cut my teeth on BASIC. This was my first experience I had with programming of any sort, was programming BASIC on a TRS-80 color computer. So that shows you how old I am. But anyway, that's coming up on September 9th. Okay, so that's about it for our show. Like I said, Randall will be back next week. You won't have to look at my ugly mug, and it should be a lot of fun. We'll find out all about his adventures in the like I said, the North Atlantic or wherever he is. Guillermo, what would you like to plug? Anything you have coming up?
I guess just my YouTube channel again. People can look me up on YouTube, search for Amaral, as you probably seen my lower third or saw before. And I'm also on Twitter a lot, so that's at GAMARAL. Just add me or tweet me up or something.
And what is your YouTube channel about?
It's mostly about everything I like. So I do a lot of stuff on games. Not that much right now, but for example, my last video was about creating there is this Pico 8, which is a fantasy game console. It's kind of like a throwback to the Commodore days. You program a little game on the terminal, and then you get it running, and then you can do stuff with it. So it's basically that, but I made it an actual, instead of fantasy, just something you run on your computer. You actually have a running console there. Used a Mino board Max for that. So if you're interested in embedded and stuff like that, you can check out my channel. There's also a video on Comic-Con. So if you're going to see people dressed up, you could also check that out.
That's awesome. Yeah, I'm going to check that out because I need to start watching your channel, dude, because we're interested in all the same, well, not all the same things, but most of the same things. And so that sounds like something to be right up my alley. So I'll definitely check that out. And I encourage everyone else to check it out too. For me, you can check me out on Twit. Here on FLOSS, co-host of FLOSS, and also other programs on the Twit network, all about Android. This Week in Google occasionally. When my dog barks in the background, I do dog barking in the background. It's a great new show on the Twit network. Sorry about that.
I love that show. I love it.
Yeah, I know. It's awesome. It's just me talking and my dog barks over top of me when I talk. It's fantastic. Really entertaining. If you want to follow Floss Weekly as a show, you can do that on Twitter. We're at Floss Weekly. We're plus Floss Weekly on Google+, and we usually announce the shows, although I didn't today. I apologize for that. But you can also chat with us. So as the show's going on, we have live chat in the background. That's at irc.twit.tv. You can chat with us, ask us questions. And we try to get to those whenever we can on the show. And you can also watch live at live.twit.tv. So if you want to just watch the stream live as it happens and catch all our funny moments and things that we do before the show and after the show and all of that stuff, you can just watch us live. Watch us live. So that's it. That'll wrap it up for this edition of Floss Weekly. Be sure to tune in every week and catch what all the cool open source projects and things that we talk about, big projects, little projects, everything. Tune in every week and you'll learn something new every time. Until next week, that's all we have for this edition of FLOSS Weekly.